Welcome back everyone to this lecture on data input-output, where we're going to be discussing connecting pandas with SQL. Pandas can read and write to various SQL engines through the use of both a driver and then the 𝑠QL_alchemy Python library. There's often a lot of confusion about how this actually works with pandas and how to connect pandas with a specific SQL engine. So I want to actually relay the steps of what's happening behind the scenes, as well as what you may have to do to conduct changes to connect with your specific SQL engine. As you may already be familiar with, SQL comes in various engines like MySQL or PostgreSQL or Microsoft SQL Server, and the setup for all of these is a little different, and it also depends on what permissions you have, what the name of your database is, and so on. So really what we want to do here is show you an explanation of the general broad understanding of how pandas and Python in general connects to SQL. So step number one is to figure out what SQL engine you're actually connecting to. For just a few examples, this could be something like PostgreSQL, MySQL, MS SQL Server, Oracle, databases, etc. For our particular video lecture, we'll be using SQLite because that actually comes pre-installed with Python. That way I know anyone that was able to get this far into the course already has SQLite. Okay, step two is to then install the appropriate Python driver library. And often this just requires a quick Google search. So you would just Google search PostgreSQL plus Python, and you would quickly find that the appropriate Python driver for that is /psycopg2, or MySQL is PyMySQL, or MS SQL Server is PyODBC. And we'll actually show you a link where you can figure out what the driver library is that you should be using. So after you've done your Google search and you figured out, okay, I have to install /psycopg2 or PyMySQL, etc., you move on to step three. And this is where you use 𝑠QL_alchemy library to actually connect your SQL database with the driver. And I have a specific link here that links to the SQL documentation. You can check it out. And what I want to do is later on when we're done with these slides, I'll first go to this link to discuss a little bit more about what 𝑠QL_alchemy does. But 𝑠QL_alchemy essentially just connects Python to your actual SQL engine. It makes that connection to the driver. That way Python in general can communicate with your SQL database. Of course, as I mentioned, depending on your exact situation, things may be slightly different. So once you've done that connection with the appropriate SQL driver and 𝑠QL_alchemy, you can use that 𝑠QL_alchemy driver connection with the pandas read SQL method. So you essentially just pass in that connection as a parameter into pd.readSQL. And what's really nice about pandas, it can both read in an entire table as a data frame, or if you want to use your SQL skills first, maybe you already know a little bit of SQL, you can actually pass in and parse an entire SQL query through that connection through pandas and get only that subset of the results. So for example, you could later on pass in select everything from table, and that's SQL syntax, and you could actually pass that into pandas and then read that particular thing as a data frame. So a really important note here is we're often asked by students to help them out on trying to connect to the database at their place of work. And to be honest, it's almost impossible for us to help with your specific work databases outside of the course material, since that almost always requires knowledge of what permissions you have, what the database name is, its location or IP address, and password information. Just a lot of stuff that's really impossible for us to know from our end of things. So really, if you're having trouble with that, you should contact your IT department, and they're going to be much better suited to actually help you connect. You should also be able to use your skills in information lookup, that is to say just Googling, to easily find many online resources regarding examples for all the major SQL engines. So pretty much, if you have one of the main SQL engines, you could just Google search Oracle SQL plus Pandas or MySQL plus Pandas, and right off the bat, the top 5 results will show you really detailed examples of how to actually connect Pandas to your particular SQL database. So it's actually really easy to just answer for yourself online, and I would always encourage you to do that. Okay. So as I mentioned, for our particular example, since we don't know what SQL engine you're using, but I do know that you already have installed Python, since you're following along with Pandas, then I know you actually already have SQLite installed, since it comes with Python. So what we can do is actually use SQLite to create what is essentially a micro database, and that's going to be a temporary database that's going to be inside of your RAM. That way, once you exit the kernel or shut off your computer, you're not going to actually need to save any of that data as a database. So that's what we're going to use. So let's go ahead and get started. I'm going to jump to the Jupyter Notebook. All right, here I am at the Jupyter Notebook. Notice I've already imported Pandas as PD. As I just mentioned, we're going to be using 𝑠QL_alchemy to actually connect to the SQL engine. And if you are not using our suggested environment file, you'll just need to pip install 𝑠QL_alchemy or conda install. Okay, So I mentioned that SQL Alchemy can connect to a wide variety of SQL engines, and then basically once you've made that connection to that engine, you'll go ahead and pass in that connection to Pandas. And so the way this works is you can just Google search SQL Alchemy plus dialects. So that is SQL Alchemy plus dialects, and it should take you to the documentation page here for SQL Alchemy. Right now, this is the current release. And you'll notice that there's actually already included dialects like PostgreSQL, MySQL, SQLite, Oracle, and Microsoft SQL Server. And that's actually the top 5 most common SQL engines. And if you scroll down, however, there's pretty much external dialects for all the other major SQL engines like Amazon Redshift, or Apache Solr, or CockroachDB, etc. So you have lots of options here, like even Google Sheets you can connect technically with SQL Alchemy. What I would suggest, however, what you should do is before you actually even come to this external dialects page, is if you really do plan on using Pandas with your specific data source, for example, let's say you really wanted to use Google Sheets, then what you should do is Google search Pandas plus Google Sheets first, and then see what ends up the result. And usually you'll actually get to this page on G Sheets, and for whatever reason you can check out this library. It'll take you to this library here, which then has documentation on how to actually connect. And at the end of the day, you're really just making a connection to some sort of data source. And for the most common ones, these included dialects, you'll simply just pass in a specialized string code. So what we're going to do is we're going to show you how to create a temporary database inside of your RAM. So what we're going to do is we'll say from SQL Alchemy import create engine, and then we'll say temporary database is equal to create engine, and then type exactly as I do here, SQLite : // memory : and what this does is it just creates a temporary SQLite database inside of your computer's RAM. So you run that and it will create this temporary database. So obviously then the next question I get here from students is, hey, what should I actually type in here if I wanted to connect, for example, to my PostgreSQL database? And technically it's a little hard for me to give you the exact answer, but what you should do, of course, is first Google search Pandas or Python plus PostgreSQL, or you can come to the dialects page here on SQL Alchemy, and again, you'll notice it's actually included here, PostgreSQL. So what this does is you come over to PostgreSQL, and it's going to end up using most likely scikit-learn. So most likely as you read this documentation, you'll realize that you'll have to install this additional library in order for SQL Alchemy to connect to PostgreSQL. But you can continue down, and if you don't want to use scikit-learn directly, you just scroll down here, and eventually you'll actually see that you do end up using this same option of this create engine command. But what you're going to end up doing is you're going to type in a different string code. And you'll notice that the string codes that are actually typed here are something like PostgreSQL, its location, your username, possibly your password, the database, and the table you're looking for. So as you begin to scroll down here, it'll eventually show you the generalized form. And usually the easiest way to find this is if you come over here on dialects, you'll notice that towards the very top, it gave you a list of options for how to actually connect to PostgreSQL. It does it from most common to least common, so you're going to probably be using scikit-learn. So go ahead and click on scikit-learn. It'll drop you down for support using SQL Alchemy, connecting with scikit-learn. And essentially, once you've installed scikit-learn, it gives you that particular connection string. So what does this connection string look like? It's PostgreSQL plus scikit-learn, then the user, the password at host, your port number, the database name, and then possibly also the table value, depending on what actually you want to do here. So then you can see different examples here of the strings being passed in to the create engine command. Okay, so in general, you're going to decide based off your dialect. For example, let's go to MySQL. So we'll come back here. Let's actually just go back to dialects. We'll come to MySQL. You decide on what actual client you're trying to use here. Let's say you decide to use PyMySQL. After installing PyMySQL, it comes down and it gives you the actual connection string. In this case, it's MySQL plus MySQL, and then username, the password, the host, the database name, etc. Again, usually the easiest way to do this is just do a Google search, and most likely then you'll actually see the links to the documentation. But this is why it's a little difficult for me to give you a straight answer as far as what you should literally be typing in, because it's all dependent on your username, the password, and the actual location of your database, such as its IP address and where it actually lives. Things that I can't really know from my end. But pretty much the dialect documentation is pretty clear on what you should be typing in, and you can always ask your IT team to help if they happen to be password protecting your particular databases. But you should also see that a simple Google search will usually show you examples and installation, so it's usually quite clear on how to connect. Okay, so in our case, since I don't know what particular SQL engines you have available or that you can install, if you come this far into the course, I know you were able to install Python, which means you've already installed SQLite. So you should be able to just create this temporary SQLite engine inside of your computer's memory. So we have this temporary database, and this temporary database is currently empty. So let's go ahead and actually just create or grab a very simple data frame. So I'll create a data frame here. We'll say simple data, or actually let's just say pd.dataframe. And I'm also going to import NumPy here just to get some random data. We'll say import NumPy as np. And then for the data, I'll say it's np random dot. Let's just make it some random integers. So the random integers, I'm just going to say they go from, let's say 0 to 100. And then finally the size, let's go ahead and make this be a 4x4. So that's the data. And then let's go ahead and also provide some columns. Let's make the columns A, B, C, and D. And if you want, you can use the separate data frames if you've been following along, as they'll have those in memory. But I'm just going to say df is equal to this data frame. Really use any data frame you want. It can be simpler than this. But you can see here, I just created a very simple data frame. Again, using what we already know about NumPy to just create a 4x4 NumPy array, and then the columns A, B, C, D. Has to be 4 columns since I have a 4x4 matrix. Okay, so now I have this data frame. Let's imagine that I actually wanted to create a new table into my database. Then I'm going to say df to SQL, and then the main parameters are this name and this connection, which essentially allow you to actually check if there's a table that already exists there, and if so, you can either make it fail or overwrite, which is this if exists argument. So what I'll do here is let's go ahead and provide the name of the new table, which I'm just going to call new_table. And then the connect command or the connection is this actual engine. So obviously if you're working with a different engine, you'd provide a different string here, but everyone should be able to follow along, provide this. And then we'll go ahead and have temporary database. So we have our temporary database connection. We've created a new table. So I'm going to take this data frame right here and write it into my temporary database. So we go ahead and run that. And now this data frame is a table inside of my database. Now let's imagine I tried to run this cell twice. So I'm actually going to display this by putting it in the cell below. So if you try running this again, it says, hey, value error, table already exists. And it's essentially a way to make sure that you don't accidentally reach into your SQL engine and overwrite an entire table. That could be extremely dangerous, especially if your company or your place of work or other coworkers depend on grabbing data from that SQL database themselves. So that's why the default, if we expand this, the default if exists option is this string is equal to fail, which means if you scroll down here, you'll see if exists, there's different options here. If the table already exists, you can have it just fail, which is the default. It just raises a value error and does not overwrite any information. You can have it replace. This is probably the most dangerous because it's actually going to drop the table in your SQL database and then replace it with your data frame. Or you can append, which is going to insert new values to the existing table. Obviously, I can't tell you which one to choose here because it really depends on what you're actually trying to accomplish. But in general, always be really careful with replace because you could easily accidentally overwrite an entire database, and then it can be really tricky to try to get that information back. And at that point, it's not something you can really do with Pandas. You'd have to actually jump into the database and then hope you've been backing it up. All right, so for right now, I'm not going to attempt to overwrite this or anything. I'm just going to keep it, and right now I have my database, and there's a very simple table in it called new table. So now that this database exists and it has a table in it, let's actually grab information or read from the SQL database. And there's two main ways you can do this. One is to read in an entire table at once. Keep in mind, if you have a very large table, you probably don't want to do this because Pandas holds the data frames in its RAM. So if you have a table in a very large SQL engine that, who knows, maybe it's a 50 gigabyte table, absolutely huge, Pandas is not going to be able to read that in unless you have at least 50 gigabytes of RAM. Again, that's a pretty extreme case, but who knows? It really depends on what and the size of your database is actually occurring. So we're going to say PD read SQL, and let's show you first how to actually read in an entire table first. So I want to read an entire table. What I'll do is say SQL, and then you pass in the name of the table. So in this case, I called my table new table, and then you have to actually tell it what database this table is in, which is the connection argument again, and it's going to be the same as last time. You essentially tell it, okay, it goes to this engine. So now we'll say new df is equal to pd.read SQL, run that, and if I take a look at new df, notice that it has this additional index parameter, and that's because when I said over here to SQL, I didn't actually specify that index is equal to false. As we've known and seen before, when you're writing something, you may want to say index is false because you may not actually want to save the default index of 0, 1, 2, 3. So just keep that in mind. That's also another option there for you. So we had this new data frame, so we can say pd.read SQL if we just want to read in an entire table. And so right now the table inside this database exists and it actually has 5 columns, an index column, A, B, C, and D. So what's the other way you can read in from SQL? Well, you can actually pass in an entire SQL query into Pandas, and it will first perform that query and then return the results as a data frame. So let's go ahead and see that. We're going to say pd.read SQL query, and then you actually provide a SQL query as a string. Keep in mind, this does require you to know SQL syntax. So I'm going to say select, and let's select the A column and the C column from new table. Again, this is actual SQL syntax. If you're not familiar with this, then don't worry about it. But hopefully you can see if you are familiar with this, this is pretty cool, that you can first do any filtering in SQL, so you can leverage your current existing SQL skills. And then we'll make a connection called temp.db, and let's go ahead and save this as result. You run that, and so it actually executed this SQL query, which means just select columns A and C from this table. So if I take a look at the result, it's only columns A and C. Pretty cool. All right, so that's the very basics. Again, there's going to be a lot of work you have to do. Main piece of work here is creating that engine and making that connection correct. But once you've made that connection, all you need to do is pass that connection to either to SQL or read SQL or read SQL query, depending on what you want to do here. And as I keep mentioning, Google is definitely a friend here. There's actually lots of already existing libraries for pretty much any major SQL engine. And sometimes it's easier just to use the library directly instead of trying to commingle Pandas with that library. It, again, depends on what you're trying to accomplish. All right, thanks, and I'll see you at the next lecture.